Hi there, welcome to this part 2 of Java Freshers interview questions. We are looking at all the typical questions which are asked of freshers when they attend interviews for Java. In the previous video, in part 1, we looked at what is platform independence, why is Java so popular, difference between C++ and Java, understood the basics of object-oriented programming like encapsulation, abstraction, inheritance, polymorphism, pass by value and pass by reference. In this video, we'll focus on things like static versus instance variables. What is a package? What are the different access modifiers? What is final variable? What is the difference between overloading and overriding? Overloading and overriding, and what is an interface, and what are the differences between abstract class and interface. So you see a varied list of topics on the screen right now. So these are all the different list of topics that we would try and cover during this particular video. So let's get started. The first question that we would want to discuss is what is the difference between a static and instance variable. We hear a lot about this static instance. Okay, the way you can think about static variables is these are class level variables. So one class will only have one instance. So if I have a variable and it's static, then it's at the level of a class. What is an instance variable? An instance variable is something which is at the level of an object. So I have a class. For a class, I can create any number of objects, right? I mean, I have an example class and I can create any number of objects to it. So example class is a class and I'm creating a new instance of it called new example class. So example 1 is now a new instance of the example class. Now I can create another one. So example 2. So this is the second instance. So this is the first instance and this is the second instance of this particular class. But there is just one class. So there is one class, but there are two instances. So now let's say I'm creating another one. So example class 3. So there are now three instances of the same class. That's three objects. So each of these is an object and this is the class. So that's one important thing you need to understand. What is an instance and what is a class? Instance is nothing but an object. Here ex1, ex2, ex3 are all objects, that is instances, whereas the example class is a class, that's a blueprint. So static variables exist at the level of a class. So the entire example class has one static variable. So even if I create three objects for it, there would be only one static variable. So if there's a static variable, there would only be one instance of that static variable. However, for all the instance variables, that is variables which are not static, example 1 would have a value, example 2 would have a value, example 3 would have a different value possibly. So let's look at a clear example to understand what a static variable really means. So how do you create a static variable? Is by putting the keyword static. So you just this would be a normal variable. If I just put static in front of it, it becomes a static variable. So the way you access a static variable is it can be the same as a instance variable, or you can access it using the class name. So here you look at it, this is static example is the name of the class, so I'm putting the name of the class dot static variable and I'm setting a value to it. So that's one way you can access a static variable, and we can look at a class which is using this particular thing. So you can see that I'm creating an instance of this static example class called new static example. I can access static example dot get static variable. So that's possible. So you can access it through an instance, or I could use the class. So static variables, I can access them through the class itself or through the instance itself. So I can use this as well to access the variable. So that's possible. But if it was a non-static variable, that's not possible. So if it's an instance variable, then you cannot access it through a class name. So if I, let's say in this particular example, I try to access, we know that the static example class has a non-static variable and a non-static method. So these are instance methods. So you can say non-static and non-static. So these variables if I try to do it through static example through the class, they are not available because you need an instance, so they are only available. So if I do this, you don't see the non-static methods. There is no get non-static variable and there is no set non-static variable methods. But if I do it through the instance, so static example 1 is an instance of the static example class. If I do through an instance, you'd see that there is a set non-static variable and the get non-static variable methods. So the main difference between static and non-static variables, or static and instance variables, is that static variables are at class level, the non-static variables are at instance level. And to access instance variables, you need an instance, you need an object. You cannot access non-static variables, that is instance variables. You cannot access instance variables through the class name itself. However, the static variables can be referred through either the class name itself or through an instance. But static variables, since they are at the class level, it's ideal not to do this. So if you want to access a static variable, I would actually put the class name and use the static variable. So whenever you want something to be the same at the class level, then you would call it static. These static variables are usually used to define something like a constant. So you would put a public static final and define a constant. So that is a very good example of a good static method. As much as possible, static variables should be avoided because it's not considered to be a good practice to use a lot of static variables and static methods, because static variables and static methods do not allow a lot of object-oriented programming. So you have to avoid static variables as much as possible. So that's about static variables and instance variables. Let's now move on to a different topic. Next question we want to discuss is, what is a package? What is a package? When we write Java programs, we write a number of classes. So there might be 100 different classes in a Java application. So how do you organize these classes? So how do you know that I organize all the classes properly? So that's where packages come in. If you look at this particular thing, I have a lot of packages here. So each one of these is a package. So I put all the examples related to constructors in this package com Ritu's tutorial Java constructors. I put all the classes related to date in this particular package. I put all the examples related to exception in this particular package. I put all the examples related to logging in different package. So packages help you to organize things into different folders. So you can almost think of this like a folder on your desktop. So we create folders to put different files in them. So if I have, let's say, 10 versions of my resume, I put all of them in a folder called resume, so that I know when I want a resume, I can go to the folder and get it. Similar to that, these packages are used to organize different classes. So if you look at these classes, all the things which are related to inner class, I'm putting them in this particular package. So the way you would represent a package in Java is by the first line of the code. So the first line of a class represents the package definition. So package and the name of the package. So also the name of the package would be going from very generic to very specific. So com is the general domain. I'm talking about Ritu's. Then I'm creating a tutorial. What tutorial it is? It is Java. What topic am I covering here? Inner class. So if you see, this is very generic and this is very specific. So in package, we move from very generic to very specific items. So this is a package. So package is something which is used to organize your classes into proper fold. The next thing we'll discuss is something called access modifiers. There are 4 different access modifiers which are used in Java. This is default. If you don't put any modifier before a variable in a class, it's called a default variable. So this is a default variable. If I put a public before a variable, then it's a public variable. If I put private, then it's a private variable. If I put protected, it's a protected variable. So these are the 4 different access control things that you can put in front of a variable. These are called access modifiers. You can also put access modifiers in front of a method. So I can call a method public, or I can call a method private, or I can say it's protected, or I can leave it as it is, then it means it's default. So the same things that we are going to talk about variables would also apply to methods. So access modifiers are applicable to both variables and also to methods. So now let's look at how these how these access modifiers are different. The most restrictive level is called a private variable. So once you have a private variable, the private variable, you will not be able to access it from outside this particular class. So if I want to set a value to this particular variable, I can do something of this kind. I can saying private variable is equal to 5. I'm setting a value to it. But outside this class, so outside this example class, you will not be able to access this private variable anywhere. So that's private. Private is private for this particular class. The next access level which is important is a default variable. A default variable is available in this particular class. I mean, this is default level, so you can use this in this class and also in all other classes in the same package. So I'm creating here this is the example class that we are looking at. I've created another class in the same package. So this is called test class in the same package. So I'm creating another class in the same package. You can see the package is the same. So it's the package is com.reduce member modifiers access. So if I go to this particular class and look at it, you'd see that I'm able to access public variables, but I'm not able to access private variables. But the most important thing is that we are talking about is you are able to access default variables. So inside the package, like this is a class in the same package. This is the class which is in the same package as the example class, and so you would be able to access the default variable in here. However, if I'm trying to go to a different package, let's just say I'm going to a different package. So I'll not go to this package. So this is example class is here. This is in the same package. However, this is in a different package. This is a test class in a different package. So in a different package, you can see that if I comment this code, so if I say example.default variable is equal to 5, it gives me a compilation error, because in a different package, the default variable is not visible. Default variable is only visible in the same package, so it should be in the same package. This test class is in the same package as the example class, and therefore you'd be able to access default variables and default methods. However, if you are in a different package, the default variables are not visible. So that's about the default variable. So first we talked about private variables. Private variables are only visible inside the current class, so it's only available in the example class. If you go to test class in same package or test class in different package, they'll not be visible. However, the default variables are visible in the same package. So in same package, other classes in the same package, it's visible. So in test class in the same package, it's visible. However, in test class in different package, it's not visible, because in a different package, it's not visible. So default variable is visible in this class and also in classes of the same package. And protected variables are visible in this class, in classes in the same package, and also in the subclasses of this particular class. So let's take a test class in a different package. So this is a subclass in a different package. What do you mean by a subclass? If you look at it, it extends the example class. So that's why I'm calling it a sub. So this particular subclass in different package, it's in a different package. So if you look at the package name for this particular example class, the package name is com reduce member modifiers access. However, for this particular one, it's access dot different. So the packages are different. However, this particular class is extending example class. So it's extending the example class. So it's a subclass of the example class. In a subclass, you would be able to access the protected variable. So I'm able to access the protected variable and set a value. So that is the main difference between default and protected variables. Default variables are not visible in different package. Whether it's a subclass or not, it doesn't really matter. If it's a different package, it's not visible. However, the protected variables are visible in all the subclasses of this particular class. So any subclass of this particular class has access to this protected variable, and also it's visible in the same package. So if any class in this package has access to this protected variable, so each one of them is one level above the other. So private variable you can only access in the same class. Default variable you can access it in the same class, and you can access it in the different class in the same package, but outside the package you will not be able to access it. Protected variables, you can access them in the same class, in the same package, and also in subclasses. The subclass can be in the same package or in a different package. It doesn't really matter. The public variable, on the other hand, is available everywhere. So anywhere in the entire thing, you can access the public variable. So you can, if you create this instance of this particular class anywhere, through that you would be able to access a public variable. So similar to variables, the same things applies to methods as well. So let's now move on to a different topic. So that's basically about the access modifiers. The next topic that we would talk about is final modifier. Final is quite a favorite question of interviewers. What is a final variable? So let's look at a final variable right now. In this example, we have a lot of final things. We have a final variable, we have a final class. Final class, the name is final class, but actually it becomes final because of this final keyword. So final class, and we have a final method. So what is final? Final in Java usually represents something which cannot be modified or overridden. So when I call something final, it means that it cannot be the value cannot be changed, or it means that the method cannot be overridden, or it means that the class cannot be extended. So it would mean one of those two things. When I call a particular variable as final, it means that you cannot change the value of this particular thing at a later point. So if I'm calling this variable as final and I'm trying to do this dot value is equal to 10, is that allowed? No, because it's a final variable. So the final field cannot be assigned. So the value of a final variable cannot be modified. Once a default value is set, the final variable's value cannot be changed. Now let's see what a final method is. So a final method, if you see, this is a class where I have one method which is final. So and we have a test class which is extending this particular class. So I'm extending this class. But if, let's say, I'm trying to override this method, if I'm trying to override this particular method in here, so I'm trying to override the method from the previous, so you'd see that I would get a compilation error. So this is what is a final method. A final method cannot be overridden. So once you call a method final, in the subclasses you cannot have a method overriding that particular method. So this method cannot be overridden. If I'm trying to override that method even without the final keyword, it would give me an error. So a final method cannot be overridden. So that's the most important thing. So a final method cannot be overridden. So you cannot override a final method. And similarly, a final class. So I have a final class here. So final class, final class. So if I try to create a class extending this final class, so class example1 extends class example final class extends final class. Is that allowed? You can see that it's not allowed. It's giving me a compilation error. The type example final class cannot subclass final class final class. So this is the final class. So you cannot extend that particular thing. So basically the way you can think about it is final variables cannot be modified. So if I have to write it down, it would look something of this kind. Final variables cannot be modified. Final methods cannot be overridden. You cannot override them. And final classes cannot be extended. So you cannot extend a final class. So that's the important things about a final variable in Java. So now let's look at another important question, which is overloading versus overriding. What is overloading? So you have a foo and a bar. So and the bar class extends foo class. So we have a class foo and we have a class bar. Bar is extending the foo class. I have a method do it with the same. If I have similar method as in foo in bar, this is called overriding, because I have exactly the same method with same signature in the subclass. This is called overriding. I can do different things here. So I can do here system.out.println test, and here I can put something else. I can test 1 2 3. So I can do different things in the overriding method, but the important thing is it should have the same signature. The signature should be the same. This is called overriding. When I override a method and I call it using the subclass, then the subclass method is called. So if I create an instance of bar and call the variable, then it calls the subclass method. If I call an instance of foo and call the method, then it calls the superclass method. So this is basically what is called overriding. So overloading is when you have a method with the same name but a different signature. So name is same, but the signature is different. So instead of a number, I'm using a string here. So this is called overloading. So I have a method with the same name. So the name of the method is doIt here. doIt is the same. However, the parameter which is passed here is integer, here is string. This is called overloading. Overloading is when you have a method with the same name, however with different kinds of parameters. This is what is called overloading. The most important thing to note is you cannot say, I can say int number. So this is now overriding because I have the name of the method same and the parameters are also same. So this is overriding. However, I cannot just distinguish methods based on just the return parameter. Here it's void. I cannot have a different return type here. This should always be void. So you cannot change the return type and call it overloading. In overloading, only the parameters can be different. So I can have instead of an integer parameter, I can have a string parameter. That's basically what is called overriding and overloading. So that's basically the difference between overriding and overloading. Next, we discuss what is an interface. Here I'm creating a sample interface, and the name of the interface I'm giving it as a sample interface. The most important thing about interface is it represents what are the different actions a particular class can do. So let's take a bird. So let's say I want to create a class called bird. So I have a class called bird and I have a class called airplane. I have a class called airplane. Even though there is no relationship between bird and airplane, there is one common thing among them. They both can fly. So I can create an interface called flyable. So I can create an interface called flyable and say the fly method. So I'll say void fly. So this is a method which the interface is implementing. Now the common thing is now this particular class can implement flyable. So an airplane can fly and also a bird can fly. So this is, it gives me a compilation error because I need to add the definition for fly. So I can say here bird is flying. Here I can say airplane is flying. So interface represents a common functionality, a common action that two different classes can perform. Here flyable is a action. So I can fly. So bird can fly, airplane can fly. So the most important difference between an interface and a class is that interfaces represents actions, whereas class represents nouns. So bird is a noun. It's name of something. Airplane is a noun. It's a name of something. Flyable represents something the object is doing. So it represents actions. So usually interfaces are used to represent common actions between different particular things. So the common functionality between two classes can be put as an interface. So that's basically what an interface is. And when we go into the details of an interface, anything that you have inside an interface is a constant. So you don't need to really say anything as anything in an interface is public, static, final. So you don't really need to put anything there. Even if you don't have it there, by default it's public, static and final. And also you cannot define the methods in an interface. So you cannot say I want to do this method. What is the definition of that particular method in here? You can only say the signature of the method. An interface cannot contain the definition of the method. It can only contain the signature of the method. So that's a very important thing about a interface. So now let's discuss another important concept, which is what is the difference between an abstract class and an interface. So we talked about an interface. Interface represents actions that a class can perform. What is an abstract class then? I mean, in interface we cannot define the methods, so they are abstract methods. So is there any relationship between an abstract class and an interface? This is quite a common interview question that is asked. What's the difference between an abstract class and an interface? The first difference I would always talk about in terms of concepts is an interface represents actions that a class can perform. So all the names of the interface would be something like a action. So runnable is an interface. Flyable is an interface. So those are all different actions. Whereas the abstract classes are also classes. I mean, they're just a type of a class. So the abstract classes represents a noun. So abstract class is actually representing a noun in terms of it represents some object, object inside the problem domain. So when I really get into the definition of an abstract class, the definition of the abstract class is that you cannot create an instance of an abstract class. So if I call any class abstract, then it means I cannot do a new operator on this. So I cannot say now here, let's say I'm creating just a temporary variable. So abstract class example test is equal to new abstract class example. This is not allowed because an abstract class cannot be instantiated. So that's what it's saying, cannot instantiate the type abstract class example, because abstract class cannot be instantiated. So an abstract class cannot be, you cannot create an instance of an abstract class. So a lot of times you have a lot of common functionality between classes, between objects of the same type. Then you would create an abstract class and put all the common functionality in there. But this common functionality might not be complete. I mean, you might need really to create a subclass to complete it. So in those kind of scenarios, you will make the superclass as abstract. So that's the scenario in which you would use an abstract class. When we really come to the syntactic differences between abstract class and an interface, in an interface, all the methods are by default public, static, final. So they are all public, they are all static and final, and all the variables that you declare there are also public, static, final. So they are constants. In an interface, you cannot have an instance variable. They are all static variables. However, in an abstract class, you can have static variables, you can have static methods, and also you can have the definition of a method. So you can define methods in an abstract class. In an interface, you cannot define methods. So here I'm defining what this abstract method should do. So that's also another difference between an abstract class and interface. And another important thing is you can implement multiple interfaces. When you extend an abstract class, you can only extend one abstract class because you can only extend one class at a time in Java. But you can implement multiple interfaces. So if this question comes up in an interview, the best answer to give is an abstract class usually is another class. So it's a noun. However, interface represents actions like flyable, runnable, and all those kind of stuff. When it really comes to the syntax of the thing, an abstract class can contain definition of methods. An abstract class can contain non-static methods like instance methods, and an abstract class, you can only extend one instance of you can only extend one abstract class. However, you can extend multiple interfaces. These are the most important differences between an interface and abstract class. Next topic we are going to discuss is what is an anonymous class. An anonymous class is something which doesn't really have a name. So when do we use an anonymous name? So let's say I'm implementing a comparator. So here I want to implement a comparator where here you can look at this particular thing where I'm directly creating a comparator by implementing the compare method. However, I have not given any name to this particular class. So this particular class is extending the new comparator of string, but I have not really given any name to this. This is what is called an anonymous class. An anonymous class doesn't have a name. So I'm here directly creating a class, overriding the compare method. So I'm saying new comparator, and within open bracket, close bracket, I'm implementing the method compare. So this is an example of an anonymous class. This is a class which doesn't have a name. So you would use anonymous class when you know that you are only going to use this particular class once. So in that kind of situations, you don't really need to create a separate class and do that kind of stuff. So ideally, I won't recommend going for an anonymous class. But in certain circumstances where you are actually creating very small amount of functionality like this, it's okay to use an anonymous class. Next question which we are going to talk about is what are wrapper classes. Wrapper classes is also a very important thing which we use frequently. So we have all the primitive variables like int, double, float. So the wrapper classes is nothing but a class representing the primitive variables. So here I have a wrapper class of integer, integer. So for the type int. So the important thing about a wrapper class is they give more functionality. So you can probably create, if I want to really create a number using a string, the wrapper class gives me that functionality. So I can directly create a number using a string. I can create a float using a string. So that's, you don't need to really do a parse and all that kind of stuff. So you can directly create a float by passing a string parameter to it. So wrapper classes are really actually things that represent primitives. The primitive variables like int, float, double, and those kind of stuff. However, it gives more functionality to those primitive variables. Character is a wrapper class. This represents the for char. Boolean is a wrapper class. Boolean, you can create it using any of these constructors. So any variation of the word true. So caps small doesn't matter, but any variation of the word true would be stored as a true. So anything else would be stored as false. One important thing is wrapper objects are immutable, like string. That's basically once you create a value of a wrapper class, you cannot change the value of it. So once I'm creating a true variable, you cannot change the true variable. You can, if even if you assign it, let's say b1 is equal to false, let's just say, I can change the value, but this false would be a new variable. So that's basically what is meant by immutability. So immutability is once an object is created, the value inside it cannot be changed. So wrapper objects are immutable, and wrapper objects also provide a lot of value of methods. So you can see integer.value of 111 comma 2. So this is which system you are using. So 2 is binary, 8 is octal, 10 is decimal. It's not really important, but if you have to understand that, probably you can look it up somewhere. So you can also pass the number system that you would want to use to the value of method. You can also pass a string, and by default it would use decimal. And there are a lot of other functionalities which are present in wrapper classes. The most important functionality that we would look at now is called auto boxing. So you can create integer 10 is equal to new integer of 10, or you can say integer 9 is equal to 9. In earlier versions of Java, before Java 5, this is not really possible. So you cannot do this. You have to always do new integer of 9. Here this is possible because of auto boxing. The compiler automatically creates the code for new integer of 9. And also the other important thing you can do is 10 plus plus. So similar to doing, it's as if this is a primitive. So 10 plus plus. So this is also possible only because it's a wrapper object. So this is also very important thing about the wrapper objects, auto boxing. Auto boxing is a very important concept. So that's about the wrapper classes. The last two topics that we are going to discuss are variable arguments and toString. So what is variable arguments? So let's see what variable arguments is all about. So if you look at this particular method, usually when I have a main method, how many arguments can I pass to it? One argument. Any method in Java, usually you would be able to pass in specific number of parameters. You can either call it with 1 parameter, 2 parameters, or 3 parameters. So there is a specific number of parameters. But what do you do when you don't know how many parameters you would have when calling a method? So if I don't know how many parameters I'm calling it with, sometimes I'll call with 2 parameters, sometimes I'll call with 3 parameters, sometimes I'll call with 4 parameters. In those kind of situations, I would go for variable arguments. So you look at it here. So the variable arguments are represented by using ... So when I say this, this means that I'm going to create a variable argument. So now this sum is a function which accepts variable arguments. That means I can call sum with any number of parameters. You can see here I'm calling the sum method with here 3 parameters, here I'm calling with 4 parameters, and here I'm calling with no parameters. So that's basically what variable arguments allow you to do. So variable arguments allow you to call a method with any number of parameters. There's a really good video, which 10-15 minute video on variable arguments in our channel. You can look it up if you want to understand everything about a variable argument. However, the important thing to remember is a variable argument allows you to call a method with any number of parameters. And once you have this numbers declared as a variable argument, inside the method, numbers is almost like an array. So you can do a loop around it and you can identify all the parameters. So you would almost get it like an array inside this particular method, and you can do everything inside this method as an array. So that's basically what variable arguments are all about. As I said before, you can look up the video on variable arguments for more details on our channel. And the last topic that we are going to discuss is toString. So toString is a very important thing. So here I have an animal class with a constructor and two member variables, name and type, and I'm creating a toString. So return, I'm returning what is the representation of that particular animal. So a toString is usually a representation, text representation of this particular object. Usually toString is used when you want to print something to the log. If you don't have a toString method, then Java by itself provides a default toString method, because every class extends object and object implements a default toString method. So if you see, now it's printing something out. So I'm doing a system.out.println of animal. It does an animal.toString and prints com.reduce.animal at probably this is the memory location. But if I implement the toString method, I'm saying I'm implementing the toString method and running this program, then it prints whatever I've put in the toString. So that's toString. toString is basically to get a text representation of an object. It is what is used when you do a system.out.println or log. If you call any of these things, then you would print the toString to the log. So there you go. Those are the important topics for fresher. There are a lot of other videos on experienced interview questions also. Maybe as a fresher, it would be interesting to look at also the experienced interview questions as well. Take a look, and if you have any questions or if you want to register for a workshop, you can use the link below the video to register. Okay, until next time. Bye.